89 concrete giants, each weighing 73,000 tons, being lowered into Baltic Sea trenches with surgical precision. We're talking about an 18-kilometer underwater tunnel connecting two countries. A $10 billion project that could reshape European logistics forever. This shouldn't be possible. You can't just drop building-sized concrete blocks into the ocean and expect them to form a perfect tunnel. The engineering tolerances are so tight that a single miscalculation could create catastrophic flooding or structural failure. Yet right now, construction crews are making this reality in the waters between Denmark and Germany, defying conventional wisdom about what's achievable in marine construction. Let's find out how they're pulling off the impossible. The heart of this operation sits in Rødbyhavn, Denmark, where engineers built what might be the most ambitious concrete factory on Earth. 3 massive casting halls stretch across the coastline, each one designed for a single purpose: creating tunnel elements that will spend the next 120 years underwater. This isn't your typical construction site. The factory operates on an assembly line principle that would make automotive manufacturers jealous. 9 concrete segments per element, each requiring 30 hours of continuous pouring. We're talking about 3,300 cubic meters of concrete per segment, poured without stopping, because any interruption could create structural weaknesses that would doom the entire element. But here's where it gets really impressive. October 2024 marked a major milestone when the first special element emerged from the casting area. These aren't your standard tunnel pieces. They're 13 meters tall, roughly the height of a 4-story building, and they contain something revolutionary: a basement level packed with the tunnel's electrical and technical systems. 10 of these special elements will be placed every 2 kilometers along the tunnel route. Each one includes a lay-by in the motorway tube, allowing maintenance teams to park safely and access the basement without disrupting traffic. This design choice makes the entire tunnel cheaper and easier to maintain for the next century. The standard elements are equally impressive. 217 meters long, 42 meters wide, 9 meters high. Each one longer than 2 football fields, containing 2 motorway tubes, 2 railway tubes, and a service passage running down the middle. The reinforcing steel alone forms a skeleton so complex it takes specialized crews just to assemble the rebar cage. Once a segment is cast and cured, the formwork gets removed and the massive piece gets pushed forward toward the dry dock. This continues until 9 segments form a complete tunnel element. But before any element can leave the factory, it gets fitted with internal ballast tanks in the railway tubes. These ballast tanks are the key to the entire operation. The road section of each element is inherently heavier than the rail section, which would make the element unstable during transport and immersion. The ballast ensures perfect balance, allowing operators to position each 73,000-ton giant with precision down to 12 millimeters. 5 standard elements have already been completed, with more rolling off the production lines to meet the tight construction schedule. The factory runs like clockwork because it has to. Any delay here ripples through the entire project timeline. The scale of supporting operations is equally staggering. 15 million cubic meters of seabed had to be dredged to create the tunnel trench, requiring some of the world's largest dredging vessels, including the hopper dredger Voyomelia and Magnar, the world's largest backhoe dredger. The excavated material isn't being wasted though. It's creating 300 hectares of new recreational areas around Rødbyhavn, turning construction waste into community assets that will provide environmental benefits for generations. Getting a 73,000-ton concrete element from the factory to the seabed requires a choreographed operation that pushes marine engineering to its limits. The process starts when each completed element gets pushed forward until it reaches its position in the dry dock. Bulkheads seal both ends watertight, and the dry dock fills with water. Here's where physics gets interesting. Despite weighing more than 73,000 tons, the element floats upward as the basin fills. The hollow interior and precise engineering make it buoyant enough to rise to the surface. The element then gets towed out into the deep end of the dock, where the water level drops to match sea level. Now the real precision work begins. Tugboats transport the floating element to its final destination in the tunnel trench. But this isn't a simple towing operation. A specially built vessel monitors every aspect of the immersion process, because there's zero margin for error when you're placing building-sized objects on the ocean floor. The ballast tanks we mentioned earlier become critical now. By filling them with water, operators can keep the element perfectly balanced during descent. Sensors on the seabed and the previous element guide the operation, allowing crews to maneuver the massive structure into position with precision up to 12 millimeters. The connection process is where engineering meets artistry. A steel beam on the descending element catches a Y-shaped bracket on the previous one, locking it into horizontal position. Hydraulic arms then pull the two closely aligned elements together with tremendous force. The water trap between elements gets pumped out, creating substantial pressure difference that presses the elements together even tighter. The outer rubber gasket compresses completely, creating the first watertight seal. But that's just the beginning. Workers can now enter from the previous element to install the inner rubber gasket. This dual rubber gasket system gives the tunnel flexibility to expand and contract as water temperatures change throughout the seasons. Once the connection is complete, the tunnel trench gets filled with gravel and sand. A protective layer of stones goes on top, and over time, natural currents will cover the entire structure with sand. The tunnel essentially disappears into the seabed, becoming part of the ocean floor. The immersion fleet includes specialized vessels for each stage. The multi-purpose pontoon Maya lays a perfectly even gravel bed as foundation. Immersion pontoons 4-1 and 4-2 transport and submerge the elements. The spreader pontoon MP460 secures each element with gravel and stones along the sides. Finally, the protection layer, pontoon Vismar, adds the top stone layer for long-term structural integrity. The first immersion of a special element is scheduled for 2025 off the Danish coast. The massive dredging operation, completed in 2024, removed nearly 15 million cubic meters of material, creating the 18-kilometer trench that will house the world's longest immersed tunnel. But there's a problem threatening this entire $10 billion engineering marvel. Germany isn't keeping up with its end of the bargain. The tunnel is scheduled for completion in 2029, but critical supporting infrastructure on the German side is falling dangerously behind schedule. The Fehmarn Sound Tunnel, which will connect the German mainland to Fehmarn Island, won't be ready until 2032. That's 3 years after the main tunnel opens. This creates an expensive dead end. Without the Fehmarn Sound connection, traffic can't flow efficiently from the German mainland to the new tunnel. The existing Fehmarn Sound Bridge is a 2-lane road with single-track railway that can't handle the projected traffic volumes. The delays get worse. Germany must also modernize the Lübeck-Puttgarden railway line, upgrading it from single-track non-electrified to double-track electrified, capable of 200 kilometers per hour. This project requires 55 kilometers of new track, 33 kilometers of upgrades, 92 bridges, and 6 new stations. To facilitate construction, the railway section north of Neustadt closed in August 2022. Rail traffic between Neustadt and Puttgarden remains suspended until at least 2028, with buses providing replacement service. The German Federal Transport Infrastructure Plan allocated 1.5 billion euros for this modernization. This follows Germany's troubling pattern with megaprojects. Based on experience, Germany has struggled with timely delivery of major infrastructure, with delays of several years becoming almost standard. The country that engineered some of the world's most impressive infrastructure now can't seem to deliver projects on schedule. The stakes couldn't be higher. Without German infrastructure upgrades, the Fehmarn Belt Tunnel becomes an isolated engineering achievement that can't fulfill its transportation potential. The entire vision of connecting Scandinavia to Central Europe efficiently depends on Germany completing its commitments. The 2008 treaty between Denmark and Germany stipulated that German hinterland connections would be upgraded. Denmark has held up its end, building the massive factory, dredging the tunnel trench, and staying on schedule for 2029 completion. Germany's delays threaten to waste this entire investment. When everything finally comes together, the transformation will be dramatic. 7-minute train rides will replace 45-minute ferry crossings. Hamburg to Copenhagen will take 2.5 hours instead of 4.5 hours. The tunnel will become the fastest route between Scandinavia and Central Europe, reshaping logistics across the continent. This project represents more than engineering excellence. It's proof that impossible challenges become possible when ambition meets precision execution. Subscribe for more stories of impossible engineering becoming reality, right here on Bigger the Better.